Hello everyone, hope you are all doing fine. Welcome back to the fourth lecture on lecture series of equivalent resistance. In this video, we are going to learn about how to apply potential point method in order to find the equivalent resistance of the given circuits. So yes, my name is Vijay Krishna and you are watching UpPhys channel. Let's get started. Okay, now let's look at the three statements here. Actually, I have explained how to apply potential point method to find the equivalent resistance in three steps. In three steps. First thing that we need to do is assign known potentials at the nodes. Known potentials at the nodes. If a circuit is given and we know the potentials at a few nodes, then we have to assign the potentials at those known potentials at those nodes. Now, for the nodes which have unknown potentials, for that we have to assign some quantities like x, y, p, q variables. Okay, and finally the resistors which are connected between same potential points, I mean the connected between same potential points are to be considered as parallel. Okay, because in parallel combination the potential difference between the 2 points or across each resistor or any electric component is same. Okay, so these are the three steps that we are going to follow. Do not mind about the statements, we don't need to by heart it, we have to practice it. Okay, so we'll be dealing with one or two examples to make you understand it even better. Okay, let's look at the examples. Okay, here we have an example. Okay, now we need to find the equivalent resistance between A and B. Find the equivalent resistance between A and B. This is the question, let's say. Okay, now the potentials that we already know are A. Here we have A, that means this point is also A, and here we have B, that means this point is B. Now, as wire is connected, there is no resistance or any other electric component here. If this potential is A, then this potential also should be A. If this potential is A, then this potential also should be A. And this potential also should be A. Right? Okay. And the potential that we don't know, I mean, the node at which we don't know the potential is this one. I am giving the name of this potential as X, let it be X. Okay, as I've already mentioned, we will name unknown potentials with x, y, p, q, whichever the variable, I mean which are the letter we like. Okay, so if this is A, this is also A, this is also A, this is also A. If this is B, this will be B. Okay, and this will be X. Right, now I'm taking A here and I'm taking A here and B here. We need to find the equivalent resistance between A and B only, right? So for that purpose, I am taking A and B at the farthest ends. Now X is somewhere between, so I am placing X here. Okay, right. Now what we are going to do is we are going to identify the resistors which are connected between A and X, or X and B, or A and B. Okay, let's identify them. A to X, how many resistors are there? A to X, this is one resistor. Okay, and A to X, this is another resistor. Okay, and we have another A to X, this is one more such resistor. And here also we have A to X, we have another resistor again. Four resistors have been connected between A and B, I mean A and X nodes. Okay, A and X potential points. Okay, that means the potential difference between these 2 points is again A and X, A minus X, this also A minus X, A minus X, A minus X, right? So potential difference is same for all the resistors, all the four resistors, so they have been connected in parallel, right? Now coming to the as we have 1, 2, 3, 4, 5, 6 resistors, right? That means we are left with 2 more resistors here. X to B, are there any resistors which are connected between X to B? X to B is this one, right? X to B is one resistor. Any other resistor which is connected between X to B? No. Are there any resistors which are connected between A and B? Here we have A and B. So this is another resistor A and B. As in the question it is mentioned, all the resistance of all the resistors are same. So this is R, this is R, all the resistances are same, right? Now let's find the equivalent resistance. As we know, all these four resistors are connected in parallel. So the equivalent resistance will be, whenever the resistors are connected in parallel, the equivalent resistance 1 by R1, 1 by R2 plus so on, whole inverse, right? If the resistance of all the resistors are same, in such case resistance in parallel is 1 by R plus 1 by R plus 1 by R n times. Okay, n times. That means n by R whole inverse, which comes out to be R by n. R by n. How many resistors are there? Each resistance is R. How many resistors are there? 4. That means equivalent resistance for this combination is R by 4. R by 4. Now this R by 4 and R are in series. Now I'm going to reduce this circuit something like this. Okay, this is A and this is B, right? Now what will be this resistance? It is R by 4 and this is R, this is again R. Now this R by 4 and R are connected in series, as you can see. If this is in series, in case of series combination, sum of all the resistances, right, plus so on. If, as we have different resistors here, so this equal combination is how much? What is it? R by 4 plus R. R by 4 plus R. 5R by 4. 5R by 4 is the equivalent resistance here. 5R by 4. Now this circuit is even reduced, so the circuit will be something like this. This is 5R by 4 and this is R. Here we have A and B. As these two resistors are connected in parallel. As these two resistors are connected in parallel, we can simplify it. We can use this formula as the resistances are different. So R equivalent is equal to 1 by 5R by 4 plus 1 by R whole inverse, right? If I simplify it, what am I getting? This is, I can even simply R1 R2 by R2 plus R1 plus R2. R1 is 5R by 4 into R2 is R, 5R by 4 plus R. Because if we have two resistors R1 and R2, then if I simplify it, I will be getting R1 R2 and in the numerator I will get R2 plus R1. If I reciprocal it, then what am I getting? R1 R2 by R1 plus R2. If I use that formula directly, I will be getting 1 R will be cancelled. Okay, so what am I getting here? In the denominator I am getting 9 by 4. In the numerator I have 5R by 4. In the numerator and denominator in the ratios we have 4. I am cancelling it out. So what am I getting? 5R by 9. Check the solution if I made any calculation error, but the process that we have followed is correct, 100% correct. I hope you have understood the steps that we have followed so far in order to solve this question, in order to apply this potential point method to solve this question, right? So what we have done exactly, we have assigned the potentials, especially known potentials first, and we assign some letters like X, Y, Z, A, P, Q, some sort of letters to the unknown potential nodes, and then we identify the resistors which are connected in between the two nodes. Okay, two nodes, potential points. Then we will be able to simplify the circuit by identifying which resistors are connected in parallel and series combinations. Okay, this is how we solve. We use potential point method to find the equivalent resistance of the given circuit. If we have one more example, we will also look into that. Okay, we have one more example. I am sure it is not clearly visible. There are many number of resistors which are, some are horizontal sort of. Okay, the image is little blurred, so you will not be able to see it clearly, I hope. Right, I don't. So these are all resistors. I'm just showing the resistors with red color. I hope you will be able to see it now. Okay, these are the resistors that are connected in the circuit, which are many, of course, but we are asked to find the equivalent resistance between A and B. Equivalent resistance between A and B is how much? This is the question that has been asked. Now, again we will follow the same steps. We will assign the known potentials first, okay, at the given nodes. This is A, which we already know, and this is again A, this is again A, and this is also A, right? So these are the potential points that we have already known. If this is B, this also B, and this also B, this node is also has to be assigned with potential B. We have unknown potentials here. Let us say this one is C and this one is D. If this is C, this also C, and this also C, and this also, this one will be D, this one will be D, and this one will also be D. Okay, we have 4 potential points, and we need to find the equivalent resistance between A and B. This is B. Okay, now let us redraw this diagram by using potential point method. Now A, B, I need to find the equivalent resistance between A and B only, right? This is B, this is B, let it be. And we have C and D are there. So I am taking C here, sorry, I am taking C here and D here. Okay, these are the 4 potential points, but we are taking A and B at the extreme ends because we need to find the equivalent resistance between these 2 potential points only. Okay, for that purpose I have taken these 2 potential points at the farthest ends. Rest of the points I am placing in between wherever is necessary. Okay, right, now solve it. So let us identify the resistors which are connected between A and C. Okay, this is A, this is C 1, this is A, this is C 2, this is A, this is C 3, AC 4. 4 resistors are there. So 1, 2, 3 and 4. 4 resistors are connected. Let us identify the resistors which are connected between C and D. C, D, C to D. 1, 2, 3, 4 again. Right? 1, 2, 3, 4 again. All the resistances are same. Okay. Now let us identify the resistors which are connected in between D and B. D to B. Okay. Again 4. 1, 2, 3 and 4. These are the 4 resistors which are connected between D and B, D and B, D and B, D and B. Okay. Now how many resistors? 4, 4, 4, 4. 16 resistors are to be there. 12 are completed and we are left with A and B. And we have resistors between A and B, something like 1, 2, 3 and 4. We are given with 16 resistors and the 16 are here. Okay, so each resistance is R, as I've already mentioned. Okay, let us say R, R, R and R. All the resistances are same. Okay, these are the 16 resistances. Okay, now the equivalent resistance of this one is how much? R by 4, R by 4, and the equivalent resistance of this one is how much? R by 4, again R by 4, and the equivalent resistance of this one how much? R by 4, R by 4, right? Now okay, now what we are going to do is, let me hold on a minute. Okay, right. Now let's all these resistors. How about this one? This is also R by 4, right? Because they are connected in parallel, right? I hope you have understood this step. They are connected in parallel. As 4 resistors are there, resistance of each resistor divided by number of resistors. Okay, right. Now the circuit is simplified as A to B, and we have R by 4 here, and we have R by 4 again, and we have another R by 4 between A and B. R by 4, R by 4, R by 4, which are in series, and here we have another R by 4. This is R by 4. It is R by 4, R by 4, R by 4, and R by 4, right? Now, as you can see, these three R by 4 resistors are connected in series, so the equivalent resistance will be between A to B, and R by 4, R by 4, R by 4 is 3R by 4, right? Because these are connected in series, right? In case of series combination of resistors, the equivalent resistance is sum of all the resistances. So R by 4, R by 4, R by 4, 3 R by 4s are there, 3 times R by 4. Okay, and we have another resistance R by 4 here, which are connected between A and B. It is R by 4. Now the circuit is further reduced. Now I want to reduce this circuit even further. As you know, these 3R by 4 and R by 4 resistors are connected in parallel. As we have identified the combination of resistors, we can apply the formulas just as we have done in the earlier example, as we have done in the earlier steps as well. So as these two are connected in parallel, the equivalent resistance between A and B is equal to R1 R2 by R1 plus R2, as these two resistors are different. Resistances of the two resistors are different. So R1 R2 by R1 plus R2, which is 3R by 4 R1, R2 is R by 4, R1 R2 by 3R by 4 R1 plus R by 4, right? Now if I take R by 4 common, 1 R by 4 will go cancelled, and we'll left with how much? 3 plus 1 is 4, 3 plus 1 is 4, and 3R by 4 is also there, right? Okay, 3R by 4 by 3 plus 4, 3R by 4 by 4 is 3R upon 16, 4 times 4, 16 is the equivalent resistance between A and B. 3R by 16 is the equivalent resistance between A and B terminals of the given circuit. Hope you have understood this entire analysis, how we have applied the potential point method in order to find this equivalent resistance of the given circuit, right? So I have followed the easiest step so that you will be able to understand it clearly, right? Let's see if there is any other example. No. Okay, so these are the examples that I have explained, that I have taken into this presentation, into this lecture. So I hope the lecture is helpful to you. If you find the lecture is helpful, please do like, share, subscribe, and don't forget to hit the bell icon in order to get the notifications as soon as I upload the videos. Okay.